All right. Hello, everyone. Welcome to today's webinar. Today we'll have our Chief Operating Officer, Paul Karam, and myself to a certain extent moderating and sharing some of your thoughts as we work together to sort of try to conceptualize the future of engineering education research and how we'd like to work together to try to figure out the future of where technology is going and how we can facilitate research in the future. Just a couple of things I'll talk about before we get started. I have a little bit of housekeeping. All of the participants who are in the webinar today will be muted. So if you need to share something, as we'll ask you to do every now and then, please click on the chat button and enter in the meeting chat window your questions, your comments. As you'll learn, this is going to be a nice interactive sharing style webinar. So we'd love for you to put into the chat window your answers to the questions we'll be posing, and we can have a nice fruitful discussion, hopefully, about how we view the future of research, as I said. You can interact with us also with little emojis if you have a response or you'd like us to pause so you can ask us a question. Unlike some of the traditional webinars, we're not going to wait till the end to have that interactive Q&A. We'll be prompting you, as I said, throughout the webinar. And if something occurs to you or you'd like to react or respond to something that Paul says, feel free to put it in the chat window or react as I said just now, and we can talk a little bit about your thoughts. This webinar is also recorded and they'll be available on demand if you'd like to rewatch it later on. And with that, I'll pass it over to Paul Karam, our Chief Operating Officer, to take us away.
All right. Well, thank you so much, Peter, and thank you everyone for joining us. We'll just turn off the cameras now, and we'll continue with the presentation. So thanks again for all of you taking the time out of your busy days to join us today, and we're very excited to actually host this webinar. We want to try to put on more of these interactive webinars. A lot of our growth and our pedigree has been built on our continued partnerships with researchers just like yourselves, with institutions like you represent, and in interacting and partnering with users and professors like yourselves. That is how our company has grown over the years, and how we plan to continue to grow and support research as all of the trends and research obligations change over time. So this webinar, we titled it "To Publish or to Perish." I mean, that is a tongue-in-cheek subject of a webinar, because we know that that's not all professors are asked to do, but it is a very important part of the life of a professor and what you're expected to do within the academic institution, and how Quanser has already partnered with institutions over the 30+ years that we've been in business, and how we plan to continue to do that, and how important it is as we continue to grow to continue to partner and learn from your needs and your research objectives, and how we can best develop and support our solutions to meet those demands of your research. So I will start by, for those of you who don't know, introducing Quanser. So Quanser comes from two words put together, question and answer, and you'll see a lot of that forms the basis of our company. And we are an academically focused company. Academia is all we do, it's all we've done from the beginning, and all we plan on doing moving forward. And that's a very important part of who we are and what we stand for, and how we continue to support researchers like yourselves. So it's always important to look back at the start of our history. We were founded by Dr. Jacob Abkarian at the University of British Columbia in Canada. And very quickly, as Jacob was teaching his control systems course at UBC, he very quickly realized that his students were getting lost in the mathematics. And really what he strived to do was to bring theory to life in laboratory experiences to really cement and synthesize what he was teaching in the lecture. And that's really what started us on this amazing journey of over almost 35 years now. You can see that has now evolved from our beginnings of servomotor control and really bringing hands-on education into undergraduate courses, all the way now through research platforms with things like controls and dynamics of various types, through aerospace into robotics, and now autonomous systems and AI. And through the pandemic, we also released digital twins, high fidelity virtual labs that complement and support all of our teaching and research products. So like I said, Quanser comes from the amalgamation of question plus answer. And, we really stand behind that, those two words about asking important questions, challenging our students, challenging ourselves and our research with important questions and working towards developing the answers to those questions. We also fundamentally believe that an engineering experience is that synergy between theory and practice. And now, the more as we come through the pandemic and have a lot more access to virtual experimentation and virtual simulations and laboratories, that synergy and that back and forth between the theory and the practice can even be more accelerated and more accessible as well. And we'll show you some of that as well. And really for this webinar, I want to focus on the last part. Our solutions have always been used for both teaching and research. So it's not that we focus necessarily on one or the other. Really, whenever we develop a solution, even though it might have a starting point, it is always designed and expected to be utilized in both teaching in terms of undergraduate labs, all the way through graduate research and beyond. So what does that actually mean? We've been, like we were saying, in this business for over 30 years. And from day one, our products, like you see on the left side, to one of our most recent products in terms of autonomy space, we still fundamentally design our products within the same pedigree, within the same approach. All our products are open architecture. We do everything we possibly can to make sure that the theory is presented, be it the equation, the transfer function, the state space modeling, or just the synthesis of what the vehicles are able to see, and make sure that there is a mathematical or scientific approach that can be taken to the experience that we're developing. And really that crystallizes in our vision. And our vision and what's our guiding star has always been to make sure that for every engineering program in the world, we strive to bring theory to life by using innovative technologies to inspire, empower, insightful discovery. And really, that's how we view what we do. We are not there to do research or to teach on your behalf or tell you how to do your job. That's never what our intention is. Our intention is to do whatever is possible within our solutions to enable you and empower you to accelerate your research and reach the goals that you've put in front of yourselves. So, in being a global company and in this academic business for over 30 years, we've had the pleasure of visiting so many universities across the globe, and each one is an opportunity for us to engage and to learn from what's happening, what are the things that keep researchers interested and teachers interested in the various parts of the world, but also an ability to synthesize all that information. And really, as a feedback company, we're always looking to how do we improve our solutions, improve our deliverables, and whatever we provide our partners in academia, we want to make sure that that's giving them as success as possible. So, as we've continued to do this, we have partnered with over 2,500 institutions and universities around the world. We have over 3,500 research papers that are published on our equipment, and that's a big part of what we're going to focus on today, is how our research solutions and our research deliverables can really empower you to hit the ground running once you establish a Quanser lab and be in a position to publish or submit research papers, fairly quickly and with an accelerated approach. Something that not all of you might know, a lot of you that have known Quanser in the past or have gone through Quanser experiences in the past really know us for our controls and dynamics plants and our solutions really in that space. But over the last 10 plus years, we've really evolved from that one core lab or core function to really broaden our horizons and into the areas and exciting areas of robotics, mechatronics, autonomy, autonomous systems, and now AI is obviously a big part of all things. And when it comes to decisions, when it comes to the application of a smart interconnected system, and how do you actually continue to deploy that on hardware and allow you to push the boundaries of where the research is taking your interests. How do we do that? How do we support research over the years? And really, there are some pillars that we focus on when we look at what we do for researchers. One of the big ones that you might not know of is we've worked, again, for over 10 years and partnering with institutions and actually co-writing or co-developing grant proposals that get submitted. Our position of being a global company and have been in this business for a very long time allows us that experience to see what resonates, what works in terms of different funding agencies and what they're looking for, and how we can partner with you to make sure that our solution as part of the grant proposal meets all the key objectives of the funding agencies and increase your chances of successfully being awarded a grant. These things include elements of outreach, which is a big part of the grants funding mechanisms that people are looking for. So not just what you're able to do in terms of your research, but also education outcomes of the research and outreach outcomes as part of the research as well. The technology is always built on student-proof or research-proof, robust and expandable hardware platforms, and you'll see some examples of that as we go through the webinar today. We've very much focus on an open and accessible platform, both from the software side of things, but also we don't limit anything into our systems. One reaction that I always enjoy getting from audiences that are coming to discuss things with us when they ask us about our drone, for example, and they say, what flight controller do you have inside the drone? And they're surprised when our answer is, there is no flight controller. Your code and your research is that flight controller. So we try to be, again, as open and academically accessible as possible. We leverage industry standard tools. So we partner with, companies like the MathWorks and work for the, we partner with them on delivering their industry standard tools, but also as we continue to expand to other areas, partnering with other platforms and other industry standards to make sure that we're meeting the researchers where they are. And then finally, that is that open architecture philosophy in all our platforms. If you were to happen to come to us at a more recent conference these days, this is what you'd be presented in terms of what you'd see of Quanser. So very much, focusing on these three core lab divisions of what we provide in terms of controls and dynamics, robotics and mechatronics, autonomy, and AI. And through the pandemic, we were challenged, and everybody was challenged with how do you continue to bring theory to life? How do you continue to provide access to Quanser solutions when everybody was home and locked out of their universities and wasn't able to access the labs that you had come to rely on? And so we very quickly, within a matter of 6 months, developed virtual twins and virtual versions of all our popular products and popular solutions. These are just a cross section of different platforms that we have digital twins for. And as we continue to evolve our digital twin or virtual lab support, we have extended that to not just be the dynamic and visual representation of the system, but to actually also simulate the sensor suite that we have on our autonomous and robotic systems. So, for example, what you're seeing here, our digital twin of our Q car not only represents the dynamic system itself, but the full solution that comes with it, plus everything the car sees down to the lens distortions. We have 6 cameras on the car, we have an IMU, we have a LiDAR. All of that is also simulated in this open environment, which really unlocks a lot of teaching capabilities and also a tremendous amount of research capabilities that we really want to get your input on as well. All right, so that just hopefully gives you a good idea of where we are, where we've been, and how we got here. And really, for the rest of this webinar, what we want to focus on is what we believe we've brought to the table when it comes to research capabilities within these 3 labs, and really open up the floor to ask you, our audience, to help us understand and realize what else is required, especially in the newer areas of autonomy, AI, robotics, and mechatronics. What else should we be focused on, should we bring to the table within our solution suite to really empower you to be as successful as possible in those areas of research as well. So like I said, we will have some leading questions for each one, and then the goal is myself and Peter will moderate the chat and take from your suggestions and commentary and have a discussion around it. And all the while, our goal is to begin the conversations with you here, but expected to continue that conversation directly with you and have make sure that you do have a partnership with Quanser, because like I said from the beginning, all our systems have evolved over time by feedback from users and making sure that whatever we're positioning and delivering to the market meets the demands of the research community.
On that note, I'll point you to the chat, everyone. Gemma's sort of asked one of our first questions we'd like to just sort of have you think about off the bat as Paul starts talking about our first collection of platforms, which is how we can assist research teams that are distributed across different institutions in different countries. There's a lot there in terms of the considerations we work with as an international worldwide company for how we create platforms that can be useful and valuable to different countries, different regions, different institutions that have different goals, whether it's finding research funding, which we'd love to assist with and help you, whether it's working on different types of local challenges, things that may not be universal, but may be very relevant and very well funded and well researched in your region. This is a question that we grapple with, and if you have any thoughts, we'd love to hear them.
Awesome. Thank you, Peter. All right. So when it comes to controls and dynamics, where, this is a very quick cross section of the products and solutions we've developed. And you can see very much our first 15 to 20 years of being in existence. The majority of our products, if not all our products, were very much focused on interesting dynamic platforms and plans to allow and facilitate experimentation and research within the control and interesting control theory that can be applied and validated on those exciting plants. And so that really made up the bulk of our solutions at the beginning. And then right around the 2010 time, we started broadening our horizons, developing mobile platforms, developing robotics, developing autonomous systems, and we continue to do that as well. But one thing that has really supported not just us as we develop our solutions, but has empowered and accelerated our customers' ability to proliferate their research is our software architecture. We call it's Quark for those of you who have used our systems, or for those who haven't or have had a seamless experience with MATLAB and Simulink and deploying that to hardware. That doesn't just happen. A lot of things have to happen behind the scenes, and that's where Quark, Quanser real-time control software comes to the forefront. What we've done with Quark is to really allow users to have very quick, low latency, single point access to I/O available in their system, be it analog encoder digital inputs, and being able to have that sampled information immediately available to your code, to your processor, so that you can compute your algorithm, and then very quickly the results of that as a control action, for example, can be applied back to the hardware. And that's the very first layer of what Quark allows you to do in terms of its hardware interface. All the while, Quark has always taken advantage of precision timing. A lot of our solutions plug into a standard Windows PC, and we take advantage of that processor to be able to time the systems and the communications back and forth. And also, as we deploy to our embedded systems and our autonomous systems, we also take advantage of the processing capabilities, be it Raspberry Pi or now more recently the NVIDIA Jetson processors, to really expand and unlock their processing and timing capabilities to, again, make sure that the plumbing is all done to allow researchers to focus on what they have to do in terms of the control theory or the autonomy theory or the network theory that you're trying to develop and research on. So Quark was built on timing, hardware I/O, a set of libraries that includes things like motion capture system, and then a big other element of Quark that has really unlocked a lot of research as well. It's communication capabilities, and you'll see a lot of that when we talk about some of our more robotics and autonomous systems as well. So here's maybe where we'll pause and maybe ask again the audience to help us. We've been very successful in this realm of controls and dynamics research for pretty much the beginning of our company. What else should we be looking at? We will put some seed questions, and maybe I'll ask sort of Peter to moderate that as well. As we continue to now go back to the conferences, we just came back from the American Controls Conference in San Diego a few weeks ago. We continually hear things like MPC, model predictive control, other types of nonlinear control, and really for us, what we're asking you and the research community is, what does that mean for Quanser? Should we focus on even more examples as these new types of control validation or algorithms, research algorithms come to the forefront? How should Quanser continue to support those things? Should we be looking at, in the realms of controls and dynamics, more distributed and network control as they become more prolific and more interesting for researchers as well? And what role, if any, does AI and machine learning play in the realm of dynamics and controls? We've partnered with MathWorks and released a great example of leveraging their reinforcement learning toolbox in training our inverted pendulum system to be able to balance itself using RL as its core approach to that training and teaching as well. Is that sufficient? Should we be doing more? Are there other elements of AI and ML that we should consider when it comes to controls and dynamics? So maybe I'll pause there, and we can have a discussion around some of the things we should be doing there before we move on.
Yeah, so if you have any thoughts, please put them in the chat. If you don't feel like writing out your thoughts, you can also just react with a thumbs up or a thumbs down or something like that to give us your ideas for how you think controls and dynamics research is headed, where you think it's headed. MPC, nonlinear control, AI, ML, those are sort of the trends that we're seeing now, but at the same time, they're all also reasonably old. MPC, I think, is about as old as Quanser is. So if there are other things that you think are emerging that we may or may not have on our radar that are going to be predominant as far as you can tell in terms of approaches to control systems and dynamics research, we'd love to hear those as well so we can support them in the future.
So maybe we will move on to the some of the other labs as well. But again, these are, like Peter was mentioning, these are just some of the ideas that, as much as we've seen success in the realm of controls and dynamics, we know it's not at its end. We know there's still very exciting research as demonstrated at the various controls conferences that we still attend, and a lot of you participate in and attend, and we we want to continue to support and meet you where you are, where you researchers as well. And I think we have a question here, so maybe Pete, if you want to take that one.
Yeah, absolutely. I mean, I think actually in your next section you'll probably touch on this, especially. Absolutely, something the integration of Quanser systems with platforms like Python and TensorFlow. That's something that we've worked to try to enable, but I think moving forward, you're absolutely right. Something that we're working on, I was actually talking to our academic manager about it yesterday, is having more guides, best practices, documentation around how to implement platforms like TensorFlow or CUDA or things like that on our system so that they're more turnkey. It's something that at this point, we've enabled, but I think probably we have some work to do to support our research colleagues in terms of making sure that it's easy and there's a path forward if the experience isn't as deep as we might have thought it could be. So absolutely, that's something that we are trying to address 100%. And Paul will talk a little bit more about how we're investing in alternative platforms that are ready for things like TensorFlow.
Well, that's a great question. Thank you, Eugene. And you know, that this is exactly where what we're seeing in you know, with our users as well. As much as traditionally controls, you know, we're very conducive to using tools like MATLAB and Simulink. Obviously, the world is changing, and there are other modalities that people want to leverage. Things like TensorFlow, things like Python as well. So that's great feedback, and that helps us quite a bit as we continue to evolve our support and our examples of how you can deploy a TensorFlow application in and around something like a Quanser Controls and Dynamics lab. So thank you so much for that.
Yeah, one thing I'd ask Eugene, if you mind sharing, would be if you are hoping to be able to use Python and TensorFlow on a desktop machine, a laptop machine, on an Ubuntu machine, or a Windows platform. Like, what is the context that you're working with, so that we can better build tools around that? As you know, we also have platforms that support NVIDIA targets, like Paul will talk about in a little bit, and there it's sort of a more closed and structured environment. But if there's a other interfacing techniques or things you're looking for, we'd love to understand exactly how you'd like to use our systems.
All right, so that actually brings us, funny enough, and this wasn't by design, to this slide right here. You know, when we released especially our self-driving car studio, we've you know, we have had these discussions, and we did know that we had to expand our software platform capabilities and software support. Easier said than done, but you know, we definitely went out and made sure that once we released this self-driving car studio built on an NVIDIA processor on a 1/10 scale car, we knew we wanted to support all of these other various tool sets and software environments, and so much so that our philosophy is always to not just, you know, enable Python, for example, but to enable all of them all at the same time. So we have customers that actually have different people within their research groups focus, you know, one group could be, or subset could be, working on Python, others could be implementing C++ algorithms, and others could be using MathWorks or ROS as well, all on the same platform, all in the same lab. So that's exciting as well. And obviously we want to continue to do that when it comes to our capabilities and especially in the area of autonomy and AI. You know, one of the things that we're very proud of, you know, we talk about research acceleration. This was our partner from the University of Aalborg University, one of our first, if not the first ever user of our autonomous vehicles research studio featuring our Q drone. And you know, we're very proud of the fact that once we went in and we commissioned this lab, they were able to publish within 3 months of having access to a Quanser studio. So that's what we mean by research acceleration. You know, things go from months to days, and you know, research goes from years to months. And really, that's a big part of what we believe our value proposition is and should continue to be as we evolve into this spaces as well. You know, one of the things we talked about, robust and rugged solutions, not just for our teaching solutions, but especially our research solutions as well. You know, this is me beating up our first ever Q drone because, you know, as much as we hope our users are nicer and gentler with our products, we know sometimes research happens and things go unstable, and our solutions should be conducive to that and facilitate that discovery, because, you know, the last thing you want to do is to have a crash in something and miss one positive to negative sign. All of a sudden you're fixing your system for a couple of weeks. That doesn't really help you accelerate your research. Um, as we continue to bring this to light, like I showed at the beginning, our digital twin and virtual capabilities are also a big part of where we believe research can thrive in the areas of autonomy and AI. So not just the access to the virtual system like we see over here, and actually being able to leverage the virtual environment to generate data sets or to uh, find, you know, create scenarios that are challenging to replicate in real life. We've also taken that to another level, where over here is a very quick, I'll you know, blush over this, and if you have any questions you can reach out to us, but this is a mixed reality demo where we are having one physical car that's operating. This is my pandemic lab in my basement for a couple of years, where we didn't have access to other labs, and how a physical car driving in an empty room or empty lab space, having its sensor suite, but also interacting with its avatar in the virtual space that's interacting with virtual cars and virtual environments, and how do we deploy classifier neural networks? How do you have a virtual car communicate its position with a physical car and back and forth as well? So these modalities are also quite interesting to us. We believe they're interesting to researchers, but in what capacity, and how do we best support researchers in these exciting fields of mixed reality and having a digital map and digital information that's fed to you from the infrastructure, for example? How can that type of research and autonomy and AI be unlocked or supported by Quanser as we continue to develop our solutions? So we'll pause again and put out some Cedar questions. For example, like, what else should we be doing when it comes to autonomy and AI? Should we just focus on more and more examples of distinct ARML applications around our solutions? Things like mixed reality, people are intrigued when we talk about it. Well, what does that mean? We have our view of it. What does that mean to you as researchers in this field? And we truly believe our digital twin capabilities, especially in our autonomous and open world systems of our virtual labs, are a very powerful tool that can be used to generate data sets, to generate scenarios, to label training data, for example, automatically. There's a lot of modalities that can be unlocked by taking advantage of a rich virtual or digital twin. But that's from our perspective, and again, we'll continue to develop our expertise in these fields, but we are looking to you as the experts in these fields to help guide us and give us that feedback into what else we should be doing when it comes to all things autonomy and AI.
Yeah, thanks, Paul. So if anyone has some thoughts on where you're seeing your research go in terms of how it complements autonomy and AI, if that's your field of interest or it's an adjacency that you think complements what you do, we'd love to hear how you are seeing those different applications of what we see in software development emerge and how they are affecting the work that you do and how we can help. So if you have any thoughts, please feel free to share. Also, no rush. We can always pause, and if you have a thought later on, and we can come back and talk about it too.
For sure. And then so as we continue to evolve, and I want to highlight some of the areas that we're developing when it comes to things like robotics and mechatronics. Again, we have our the Quanser arm, the Q arm. It's a great academically focused manipulator, a safe manipulator that you can have on a desk without having to worry about it hurting you, especially as a researcher or even your undergraduate students. And in this case, again, a mixed reality demonstration of having a mix between the physical and the virtual, and how one could drive the other and vice versa. That's one example. And some of the areas that we're looking towards, and this is definitely things we're prototyping and conceptualizing, as you can see in this video. None of this has really been developed physically yet, but these are ideas that we're having around where we believe our robotics and mechatronics systems can go. This is a digital manufacturing lab or environment, so very focused on obviously manufacturing and a factory of the future, if you will, and having an integrated set of autonomous systems, be it mobile robots, be it manipulator arms, conveyor belts, and the whole system becomes that much more intelligent because you have these intelligent autonomous systems working together and communicating and being more globally intelligent together. We believe these types of environments, these types of platforms and research labs will support the research in these exciting fields like Industry 4 and IoT, digital manufacturing, smart manufacturing. The CHIPS Act is a big part of where the U.S. is focusing on for reshoring some of these capabilities and smart manufacturing capabilities. Is that what you're seeing in your parts of the world? Is that what you're seeing in your research as well? And so we invite you, and again, doesn't have to be in just this webinar, but to continue to have the conversations with us. Are these things of interest to you, and how should we as Quanser, as we continue to evolve our robotics and mechatronics solutions, what else should we be doing, and what other solutions and experiences should we be providing to the research space when it comes to things in robotics and mechatronics? Just like I was saying, should we continue to focus on digital manufacturing, Industry 4.0? That seems like an obvious application for these amazing smart systems that can be put together in a more intelligent global system. Heterogeneous control, human machine interfaces, are these things of interest? Should we develop platforms that allow you to, for example, cobotics, or how do you have a manipulator, and a mobile robot integrate and work with one another? Are these types of examples and solutions that we should be focusing on, or are there things we're missing when it comes to the fields of robotics and mechatronics research? And again, we will continue to have digital twins of all our labs. The one thing we've learned through the pandemic, as we released and supported our customers with our digital virtual labs and digital twins of our physical systems, it's not a question of should we use virtual or physical. It's what we've realized, and what I think a lot of our customers have told us actually, is the power comes when you integrate both. So you have both for teaching and research, you utilize both. And that really, increases the scalability of our systems, the accessibility of our systems, and really what they're capable of doing. We believe there's a lot of room to grow in leveraging our virtual environments and our digital twins to produce, again, data sets and to produce scenarios that are challenging to replicate physically. But what do you think? What else should we be doing in these, exciting spaces of robotics and mechatronics, and as we continue to proliferate our solutions and our support of these fields?
Something else that I often struggle with in terms of trying to conceptualize how we can help research interests is fundamentally the top question that Paul has asked here, which is what research is currently of interest in the field of mechatronics. In my experience, which is sort of ironic, I suppose, to a certain extent, given that the research lab that I went through in graduate school was a mechatronics research lab, but I don't know what research is done specifically in the field of mechatronics. Mechatronics is a particularly hands-on and design and development oriented field, which means naturally, as a consequence, when it comes to research, it's a very particular type of application area that doesn't necessarily have the same flexibility in terms of research interests you might see coming out of traditional software development or robotics or intelligent systems or things like that, where because of the nature of them being algorithm based and more the integration of systems and their application to different challenges, there's a lot more flexibility in terms of how research can be done with mechatronics, because it's most of the time based on the creation of electromechanical systems. The research options are, I don't know, difficult to conceive of. And so if you have thoughts on what mechatronics research looks like nowadays and in the future, we'd love to hear those too.
Perfect. Thank you, Peter. So again, if you have any ideas now, would be great, and Peter and I could discuss them. And again, if not, we know that this is the beginning or part of our conversation, and let's continue our conversation. We have representatives all over the world, and wherever you happen to be, we'd love to hear from you. We'd love to learn from your experience and what you're looking forward towards. What are your challenges in your research endeavors in the future, and how can Quanser best support you as you strive to accelerate your research towards those goals? And with that, we'll leave you with a couple of fun videos that showcase our systems in various capacities. And we'll end with this slide where, we are very proud of the fact that Quanser is always viewed by our customers and our partners as colleagues and not vendors. We are very active in research. We love to geek out on our systems ourselves, and we hopefully that comes across from all your touch points with Quanser over the years as well. Thank you very much, everyone, and we look forward to meeting you where you are and talking to you over the year and years to come as well. Thank you very much.
Thanks very much, Paul. Thanks, everyone. I have a couple of last slides that we'll share just before we let you move on with your day. The first we'd like to talk about is that if, as we mentioned, you'd like to reach out to us to partner on grant applications or grant proposals, or to help us work together to find funding for the research interests you do have, there's a QR code here. We have a whole team dedicated to working with you to try to find the right funding agencies in the United States and Canada and the UK, around the world, that can help to secure funding so we can work together on whatever projects or problems you'd like to solve with your research. You can also find that on our website at quanser.com. In addition to that, if you have any answers or thoughts, or this triggers something you'd like to talk with us, as Paul said, you can reach out to our sales team. You can reach out to us on LinkedIn and share your thoughts with us. We'd love to hear what you'd like to talk about and how you think that the landscape of engineering research is changing. So anything else you'd like to share? We'll be here for a couple more minutes. Otherwise, thanks very much for coming.
Pete, I have a question.
Yeah, sure.
What other languages are we working on supporting other than?
Yeah, that's a great question. So you saw that Paul had a slide that talked a little bit about all the different languages we've already worked to support over the last few decades, from C++ to .NET to, obviously now as it emerges as I keep seeing it, the number one language in the world is Python. It keeps coming up over and over again in the statistics that we read about. We're doing quite a lot of work to support Python more and more across different platforms. But as we also all know, those numbers change when you look at those animations that talk about the statistics of usage of different languages. Even over the last 10 or 15 years, they've drastically changed in terms of how many people are using .NET versus Java versus JavaScript, coming now with Python emerging as a clear leader in the field of engineering and across the programming world. That also will change one day, I'm sure, and other languages will emerge. And we try to keep up with, as Paul said, where the research is going and how people are using different languages for their research and support them as much as possible. We're working with a group now that's going to start showcasing how the language Julia can be used with our systems. We've done some investigation in the past on other interfacing techniques and things like that. So I think the easy answer is we don't know. We'll have to see how languages emerge and how they change over time, but we'll always strive to make sure that you can use the languages that are appropriate for your research with our systems.
Okay, thank you.
Thank you, and thanks very much for everyone for coming. Have a great rest of your day.
Bye, everyone. Thank you very much.